Hello everyone. In this video, we will be solving problem 380, insert delete GetRandom. The problem statement is, we need to implement a randomized set class where we will have three methods. The first being the insert method, where we need to insert the item val into the set if it is not present. Return true if it is not present, or else return false. Another method is remove, where we need to remove the item value from the set. And the last one is getRandom. This method should return the random value from the current set of elements. The problem statement also mentions that each element must have the same probability of being returned, and it is guaranteed that there will be at least one element that will exist in the set when this method is being called. Another challenge to this problem is we need to implement the functions of the class in such a way that the average working time or the time complexity is O of 1. Now let's switch to whiteboard and talk more about the problem statement and how we can tackle it. Let's spend some time understanding the problem using this example. Starting with the first command, which is initialization, where we will be initializing the class. The next is an insert the value 1. So let's say I have this set, and I will be inserting 1 and then returning true. Next is remove 2. Because I don't have a 2 here, I will be returning false. The next is insert 2, where I will be inserting 2 to my set and then return true. The next is getRandom. Now out of the 2 elements that I have in my set, I will return one random. So it could be either 1 or 2. Let's say we return 2. The next command is remove 1. We will check if 1 exists. Yes, 1 exists, so we need to remove it. And we will return true. The next is insert 2. Now check if 2 exists. Yes, 2 already exists, so we cannot add it again. So we will return false. And the next command is again getRandom. So we will be returning 2 because we only have one element here. Now that we understand this problem, let's look at what would be the time complexity for each of our commands. So starting with insert. So for insert, we first need to check if the item already exists and then add. Check item exists. It could be O of n if we are using a HashMap, HashSet or a dictionary, and then add is also O of 1. If we do a remove, again we need to see if check exists and then remove. Here the check exists will take O of 1, but the remove will take O of n, because if it is a simple list, it will need to iterate through all of the collection to find out that one particular element and then remove it. And the last is getRandom. For this getRandom method, we need to generate a new random variable using the size of the set and use it as an index to get the corresponding value from the collection. This is simple enough. This will also take O of 1. As you can see, our insert method and our getRandom method both are using the time complexity of O of 1, but our remove is not. Now let's talk about how we can solve this problem to get that O of 1 time complexity. So instead of using just one set, I will be using two sets. One will be the dictionary of integer and integer, and I will be saving the value and its corresponding index, and this index will be the position of that value in this list. So this list is going to just maintain the collection of values. Now let's start the iteration. And while we are going through that, I will talk about how this will optimize our solution. Starting with the first one, insert 1. So in my dictionary, I will be adding 1, 0, as the index is 0 when we add that value to our list. The next is remove 2. So when we are calling remove 2, it will return false because it's not there. Let's go to the next one, insert 2. So I will be inserting 2 in my list and add it to the dictionary as well. So it will be 2, 1. 1 being the index of 2 in this collection. Now get random. So now when get random method is called, take the length of the list and then use that as an index to find out a random value and return it. So it will be something like set of I will be random value. The next method is remove one. Now the fun part starts. So whenever we want to remove a particular element which is in the middle of the collection, the time complexity is O of n. If the element is at the very end of the collection, let's say we are trying to remove 3 here, the time complexity is going to be O of 1. So we will be using this behavior or this theory to optimize our solution. So in this case, when the remove method is called with the value 1, so I will replace the current value that needs to be removed with the last value in the collection. So I will get 2, 2. I don't care about this 1 because it needs to be removed anyways. Now the question is, how do we know the index of the current value? We can find that out using our dictionary. Because our key is the value, using the value 1 and looking it up on the dictionary, I can get the corresponding index. So I am looking at 1, 0, 1 being the value, 0 being the index. So I will take this index, use it in my calculation and replace the value with the last element. I will get 2, 2, and once I get that, I can remove the last value from the collection because now I have duplicate. So after removing this, I will have 2. As you can see here, all of these calculations that I am doing is O of 1. Like replacing the element based on index is O of 1. Removing the last element is also O of 1. If you notice, the index of the value 2 has changed. Now it is 0. My dictionary still says 2, 1. So next step is to update the index. So I will make sure the index is updated. So the new value will be 2, 0. And my list will be updated to 2. Again, updating the dictionary with the new value will also be O of 1 because it's a dictionary and I am looking it up based on the key. So this operation is complete. The next operation is insert. Again, it will check for the value in my dictionary. The value already exists, so we will return false. And the last method is get random. So here we'll go through the same process but with a different data set. So I only have 2, so I don't need to do any replace and then overwrite the value and then change the index. All I need to do is just return it as is. I hope you were able to follow this explanation and this optimized solution. Let me show you how we can implement the very same solution in C#. Here is my solution in C#. In my randomized set constructor, I am initializing 3 variables. One is the dictionary of type integer and integer. The next is a nums variable, which is a list of integer to maintain the collection of values. And the last is the random that will be useful in generating a random value. Insert method, I am checking if the key exists, and if it exists, I am returning false because it's duplicate, and if it does not, then I am adding the key value, which is the value to be entered and its corresponding index to the dictionary, and then adding the value to the nums collection. The next method is the remove. So I am checking if the key exists. If it exists, then I am taking the current index of that value from the dictionary, then replace the current index with the value in the last of the collection at the end of the collection. Then I am updating the index in the dictionary to make sure that the index is not out of sync after the replace is done. The next step is to remove the value from the dictionary and the set and return true. The last method, get random, is where I am using the collection nums and building and generating a random number based on the size of the collection using the random library and returning the value at that one particular index. Thank you for watching this video. I hope you were able to understand my explanation and this solution. If you have any questions, comments or suggestions, feel free to reach out to me. If you have any better solutions on solving the problem, I would be happy to talk about that as well. Again, thank you for watching this video and I will see you in the next one.